Here we go, guys. We're going to look at these problems, which, are sample problems. Actually, they were actual tests, and they give you some kind of take on what to expect for the forthcoming test. Okay, so questions are: in which quadrant is the angle negative 16 pi over 3? So negative angles of rotation go clockwise. This negative 16 pi over 3 is negative 5 and 1/3 pi. Okay, remember every rotation is 2 pi. 2 pi, that's negative 2 pi. Okay. It's negative 4 pi. That's negative 5 pi and 1/3, so that's taking up into quadrant 2. What is the reference angle? Reference angle is always given right there, pi over 4. Evaluate the cosine of negative 3 pi over 2. Well, okay, remember, cosine is the x-coordinate, x comma y is cosine comma sine. So negative 3 pi over 2 is right there. That, of course, is 0, 1, so the cosine there is 0. Evaluate the tangent of pi. Tangent of pi, okay, that's right there. Okay, where, of course, that's negative 1 over 0. Okay, and negative 1 over 0 is cosine over the sine, so sine over the cosine is 0 over negative 1, which is 0. Okay, for tangent. What are the solutions of sine of theta equaling 0? Well, remember, the sine crosses beginning, middle, and end of the cycle, which is 0, pi, and 2 pi. However, okay, this is an open interval, so 0 and 2 pi are not inclusive. Watch out for that. Could be tricky the way it's phrased. In what quadrant is the sine function negative? Well, of course, all study trig carefully says, okay, in the sine is positive, first and second, lower quadrants, third and fourth is where it's negative. Reciprocal, the cotangent is tangent. Remember, the secant is 1 over the cosine. And of course, the cosecant is 1 over the sine. It's always that C and S combination, which I spoke of. Evaluate sine squared plus cosine squared for pi over 3. Well, for pi over 3, pi over 6, pi over 2, any value, it's always equal to 1. That's an identity. Of course, that comes from our unit circle. In our unit circle, of course, you'll remember we talked about this angle on the unit circle, radius 1, and we correlated, okay, from here, the right triangle, the sine and cosine, and you should go back and review that. It's a good concept to recall. Excuse me. Okay. Name all the x-intercepts of cosine. Okay, well, of course, cosine is said to cross a quarter of the way in and a quarter way in from the beginning, a quarter way in from the end. Okay, so that's pi over 2 and 3 pi over 2. Okay, but then the cosine is symmetric to the y-axis, so it's negative 3 pi over 2 and negative pi over 2. Explain sine of theta plus 2 pi equals sine of theta. Well, that's just going around one additional revolution. It's a periodic function. The period of the sine and the cosine is 2 pi. Periodic functions, such as all trig functions, have a unique quality, unlike any other functions we've seen. They have a regular repeating interval known as the period of the function. When the function is translated horizontally left or right by its period or wavelength or any multiple of itself, it will map right back on itself. This is the implication of the above identity statement, okay? This one we actually seen in class, okay? We actually talked about this very, very early. This is the idea behind cofunctions, okay? That cofunctions were equal for their complementary angles, okay? So the sine and the cosine are cofunctions, which implies they have a complementary relationship. That is to say, the sine of an angle, remember, sine of 30 is cosine of 60. Sine of 45 is cosine of 45, so on and so forth, okay? Let's take a look here. What is the range of the function? Well, the range is offset by the amplitude and the vertical translation. Now, the amplitude in this, okay, the amplitude will set the beginning of the range from -3 to 3, but then we're pushing it down 4, so we're going to subtract 4, which is going to give us at -7, -1. That's going to be the range of that. Okay. What is the period of the function? The period is 2 pi over b, which is 2 pi over pi over 2, which is going to equal 4 units. You check out the multiplication. Don't get trapped up with the fractions there. How many solutions does the equation sine squared of equaling 1/4 have on the first cycle? Well, if you take the square root, you get the sine of x equals 1/2. That's plus or minus 1/2. Okay, which is at all pi over 6 reference angles. Okay, that's what it says here. All pi over 6 reference angles. That's pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, which we can write as pi over 6 plus pi k, because that would give us this 7 pi over 6. That is, if we were looking over the entire domain of the function, I would write it that way. Pi over 6 plus pi k, and then, okay, which will give us a 7 pi over 6. Then we got the 5 pi over 6 plus the pi k, which would give us next the 11 pi over 6 and all subsequent values. So if this were asked over the entire domain, okay, that's what I want. And if there's no interval quoted, then that's what's understood. I want it over its entire domain. We'll come back and look at those B problems in the next video. We're going to stop here.